Okay, Assalamualaikum to Puan Saliha. Today I and Faiz will represent the lab 4, which is uh, introduction to AC fundamental with RL and RC circuit. Okay, from the multisim, we see the two components, which is function generator and the oscilloscope. Okay, a function of function generator is a piece of electronic test instrument used to generate and deliver standard waveform, typically sine and square wave to a device under test. Okay, from the multisim, we see the three waveform, which is sine waveform, triangle waveform, and square waveform. Okay, you can choose any value of the frequency from the function generator, and we can also put any value of amplitude of the function generator.
Okay, for the oscilloscope, the function for oscilloscope is to display the voltage signal as a waveform. As you can see in this multisim, this is the waveform, and in the oscilloscope you can set the time base, channel A and channel B. Time base is the X axis setting. If you change the scale, it will give a different at this place. So for the channel A and channel B is a y-axis setting. So you can change the scale. That's all about oscilloscope function.
Okay, from the oscilloscope, the way to find the period of time is that we need to find the one cycle, and we need to count the box. Okay, just for the example, the box in the simulation has a times box, which are 1, 2, 3, 4, 5, 6, 7, 8, 9 times. Okay, after we get the boxes, okay, we need to multiply with the time base, as shown as the in the laptop. In the multisim, the time base is 50 microsecond. Okay, after we multiply the time base and the division, we get the 500 microsecond. The peak to peak voltage is the maximum voltage change occurring during one cycle of alternating voltage or current. The peak to peak value of an AC voltage is defined as the difference between peak positive and peak negative. Okay, how to get a VPP? Okay, for my uh, understanding, I understand the VPP is equal to 0.5. Okay, if the lab sheet go the value of 5 VPP, okay, 5 VPP is multiply by 0.5 to get the VP. Okay, if we multiply, we get the answer is 2.5 VP. That's all.
Okay, for the part B, measuring the phase angle difference. So the answer is to find the phase angle. There is two way to find the phase angle. First using calculation and second using measurement. I will explain the first one. Calculation. If you want to use the calculation, you need to use the formula shift tan multiplied by xc over r, which is the xc value you must find using the formula 1 over 2 pi fc. And when you get the value, you just put it into the formula shift tan multiplied by xc over r. And then the measurement, you need to use the multisim. Okay, so this is the multisim and the RC circuit. So the input I put the red color and output I put the blue color, so it can we can see the difference. So this is the output from the oscilloscope. To find using measurement, you need to use the formula, which is y over d multiplied by 360, which is y is different between two signal and d is period. This y and d must be in second unit. Okay, so how to find the y and d? First, I will show you how to find difference between two signal, which is y. Okay, I will use this cursor. I will call this as a cursor 1 and cursor 2. So first we need to find the intercept of these two signal, intercept to x axis. So we need to set value, y value into the 0. So it will be here, and second one we need to change the trace first. Channel A. Wait, this is AC. Y value into the 0. And then you get here. Again. Hmm. Okay, that's the value. So you will get the difference between two signal. You will get T2 minus T1 equal to 18.906 microsecond. So this is the Y. So for the D, which is period, you must find only for one signal because they share the same period. So you must find the intercept of as it is at here at this point and this point because period is one cycle. So use the same method like that, like before this, and the y equal to 0 because we want to find the intercept at x. Oh my god. Okay, okay. Okay, so you will get the period. The period is equal to 500 microsecond. You can get here. So you can just put into the formula y over d multiplied by 360. So for the oscilloscope, you must setting first the time base, channel A and channel B until you get the perfect waveform as you like. If you change the time base, it will change the the x axis, which is the period. So we need to change until we get nice one period, perfect one period. So the for the channel A, we set for the amplitude for channel A only. Which channel A is the red one. So if we change at here, the red one will be changed. So we need to increase it until it get the nice place. Same as channel B, it will change the blue line, which is the output. We change the will change. Okay, that's how do you use the oscilloscope. And for the lead or lag, we can determine it from the beginning of starting at the starting point. Here, you can see here at this point, you can see which signal is lead or lag. So the blue line is the output and the red line is the input. We can see that uh, output is lead channel A, which is input. So we can write as output lead 82.21 degree, output lead 67.48 degree, output lead 13.56 degree, which is this is the phase angle. So for the next part is inductance RL circuit. So we can same as like that. We can use two ways, which is calculation and measurement. If you want to use the calculation, you need to use the formula. The formula is equal to shift 10 multiplied by SL over R plus RW. Okay, for the RW, it is the resistance at decade volts. So we find the RW at decade volts. So the formula shift 10 multiplied by SL over R plus RW. So we need to find the SL first, which is the formula for SL is 2 pi FL. Then we just put in the XL into the formula, which is shift 10 multiplied by XL over R plus RW. So we can get the phase angle. And the second method, we use the measurement method. Measurement method, we need to open multisim. So same, this is RC. So we pause the RC circuit first. We open the RL circuit. Same like before this, we make the difference between the input and the output. The output we use the blue color and the input we use the red color. So you can see the difference, right? So the formula is same like before this. Phase angle equal to y over d multiplied by 360. So you need to find the y first. Y is equal to difference between two signal. Okay, first you use the first cursor one to find the intercept of x value at this point. And cursor 2, you must change the trace first to be channel. Okay. Then you move it a little bit. Set the value to 0. Then you get the 0 value at x. So the difference between two signal is 87.451 microsecond. So this is the y value, which is different between two signal. Then we need to find the D, which is the period. So we need to just only on one signal because they share the same period. Okay, so we can get this period, which is, oh no, the value is equal to 0. Let's go there, equal to 0. Yes, the value equal to 0. And no, it's the channel A. So it's 0. And then, okay, you get the one period is equal to 500 microsecond. Then you just put in the formula, which is y over d multiplied by 360. So you will get the value and put in here. So for the lead and lag, as before this, we can determine from the beginning of the signal, the starting of the signal. So this is the red one is the input, right? And the blue line is the output. So we can know from this the output is lag. So we write like this. The output lag 47 degree. Output lag 64.42 degree. Output lag 73.55 degree. Okay, that's about that's all about part B. Thank you.